Good morning! Again, it's Monday. So I'm giving you the project details for our tile design. We know that we already have started this, but I just want to refresh them because I really would like you to create this project nicely. Um, this is gonna boost our grades for this marking period. Okay, so I extended the due date on May 20th. That's the most we could do. Okay, guys? So let's see a review what task number 1, 2, and 3 and 4 is. Okay, let's start. So for task number 1, the tile design was cut and paste. So I asked you guys to cut 2 different polygons. 2. Alright, so make 10 of each. So we're hoping to put this together in a 1/4 size of paper. So make sure to have the same size for each polygon. So I was hoping also for the sides to be the same. So put together in 1/4 size copy paper to create a design. Take a picture and post it and send it to your Google Classroom task. Some of you already have submitted the work, so I took a picture of it and I want to share it to you. So here are some of the pictures was uploaded. A picture of your cut and paste. Maybe I have another one. Here we go. It's another one. I only randomly selected some other designs. All right. For task number 2, or is one more for task 1? All right. For task number 2, that was given on May 5. This one is different. This is second design. So draw and color. So you own a 1/4 piece of paper. We work on this together during the class, so there should be no reason for you not to make it. So you are going to create that on a 1/4 piece of paper. Create the dollar sign using the polygon, color, and take picture and turn it. Actually, I already have given you part of this design. We did it together. All right. So that was the tile that we have created. And here are some design that your classmate did. So here are the sample project of your classmates they have created. All right. So here are some more. Whoever did this one, could be better if you could have put a triangular line. This one too, and that one too. Let's see what's next. Alright, so this is task number 3, the tile design. You already have this. So your design here, and you're going to you need 2 of this, right? 1 for design 1 and 1 for design 2. And you're gonna identify the shapes, and you're gonna identify how many of that shape was given, and number of sides in given shape is triangle, it's 3. And let n be the value of the side, assuming that all sides are equal. That's why I asked you guys before in the first task that it should have the same shapes. I mean the same sides. Expression that represents according to sides. Expression that represents according to the total number of sides. Simplify the expression. Let's see an example. So for example here, this is the tile design that we just have created, right? So in this design, we have a triangle and a square. So the triangle here, the number of shapes in the pattern, there are 12 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And number of sides of a triangle is 3. And then let n be the number of sides, assuming that all sides are equal. So here, and it's n. So even though it's a diagonal longer, we just assume that all of them are equivalent to each other. The expression that represents each shape according to the sides. So since the triangle has 3 sides, we make it 3n. I'm assuming that's equilateral triangle. expression that represents the total number of sides in the design. So there are 12 triangles and each side's at 3n. So 12 times 3n, that will represent every single side of them is 36n. And we have 6 squares, 4 of the sides, n is the value of each side, 4n. So 6 times 4n will be 24n. Write an expression that represents the entire pattern. So 36n plus 24n gives you 60n. Alright? You have to do this with your tile design 1 and tile design 2. So you should have submitted 2 of this paper. Okay? Go to the next. So for task number 4, you say, let's say for example, 1 has tile design 2. Remember the draw and color design? That is a dimension of, so whatever your length and your width is, right? So use the value of n for each sides of the polygon. Estimation is allowed. Because I've noticed that some of you created a big rectangle, small rectangle. So we'll look at that right now and we'll figure out what will be the sides for those polygons that you have created. But if you guys follow through the first instructions that we have, we will not go to that point that you have created different sizes of each polygon. If you created only 2 different polygons, there will be no problem, assuming that all sides are equal and we're just gonna create n. But anyways, you've created it already, so we'll fix the problem. We'll do it right now, okay? So let's say for example in this problem, so it's like too big and too small. And before I said make sure that the sizes of the sides are equal, but anyways, we'll fix this. So here we could represent, so we're just gonna represent this as n, right? This one is n. We could also represent this one as n. So there we go. We're just gonna represent, that would be 2n, but let's keep it for n. It's close anyway. If it is really totally like far from each other, then we'll figure it out. So the length for here, or the width, we could say this is the length. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could represent this as 9n. And the other side, that's n, 2, 3, 4. I could not see it in black, so I put it on a space, okay? But it's supposed to be on the edge. Okay, so since all of them looks like the same, so we're just gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we could represent the width as 12n. So the length will be 9 and the width will be 12n. All right, for this particular example. Okay, for this particular graph, let's look at the other example and let's like figure out how could we identify the ends, or the what is the length and the width for that one. All right, let's look at it. All right, so here's another scenario that we have, that it looks like we have 3 different shapes and 3 different lengths. So we could always represent them with n, 2n, and 3n. So if you look at this, this is smaller than this, but this is smaller than that. So we could always say that this and this is the same shape. So we could say that this is n, and that's n. Since this is a little bit bigger than that, we could say 2n. And since this is a little smaller than this, that could represent 3n. So we could say this is 2n. But anyways, as long as you label your picture accordingly, I will take it from your label for those who are already done, right? There are some of you who are already done with their labeling and work. So I will take it from the label you got. So if you label this n, I'll take it from there. Whatever your label is, I'll take it from your label. For those who are not done yet, you could really like differentiate your sizes according to the length. So since this is the longest one, I could make this 3n. And this is n, 3n, right? And this is n, and that's n, but this on the side. So now we could say, we could count what's our length and our width. 1, 2, 3, 4, 5, 6, 7, 8. So this one is 8n. And this one's 3, 4, 5, 6, 7, 8, 9, 10. And this one will be 10n. So now your length will be 8n and your width is 10n. Or you could just switch them around. It's also okay with me. Alright? So again, you could have labeled this differently. You could have labeled this n. You did not differentiate the bigger side and the longer side. I'm still okay with it, okay? I'm gonna base it to what label you have in your picture, and that will be the basis of the task question 1, task 4 question 1. All right? Okay. Here's another one that's a little bit off the shape, like we just that you guys just like crisscross it and make a tile design. It's also okay. So remember when I said you are allowed to estimate. So let's estimate this tile design for the sides. So in this case, we could say that the longer side will be 2n. So let's see, did you see the side is longer than that one? So we could say that that's 2n, and those smaller ones are n and n. So I could just make this 2n. So since that is the case, I could still make this 2n. I could make this n. Well, that's why I said we could estimate. So this is n and that's another n. Alright, on this corner we have n. We could say that's 2n because it's longer. That's another 2n. It's just like your marker is wider, so it covers the other side of it, and that will be n. So now we could count. Again, as I said, I'm gonna take it based on the level of the work that you've got. So let's see, 2, 3, 4, 5, 6, 7, 8, 9. So I could make this as 9n. And then 2, 3, 4, 5, 6, 7, 8, 9. This happened is also 9. Alright, so there you go. You could label it like that. So your length and your width is the same. Alright? And again, I could not stress this enough. You could always label them accordingly, according to what you think it should be. And I'll take it from the label that you have created. Alright, so here's another one that has freelance design. So I could, so this is longer. Let's just talk about this. It's longer than this, and this is smaller. So maybe since this is longer and they have 3 different sides in a corner, so I could make this 3n. And they're gonna be n, and they're gonna be another 3n. On this side, since it's shorter than that or smaller than that, we could make this as 2n. Oh, by the way, this is n. Could do the n, and could do the n. And there's a little bit more over here. Okay, so this is another n over here. So we'll take that. Alright, since are you allowed to estimate? I'm talking to myself, guys. So that will be it. Alright, so with that, we'd say this is 7n. And it's gonna be 2, 3, 4, 5. It makes sense though, because that's longer than this. So now you have 7n and 5n. Right? Whoever has this, and again, it depends on what you label them. I'm okay. So going back to this one, all right, remember what we have created before? We said, let's say that this was the one that has 7n, and this one, the one that has 5n. Okay, so let's take 7n and 5n. You could make like that. Okay, let's look at question number 2. So in this case, you said we have a 7n and 5n, right? So we created this before. I think that was in a previous example. So let's say that was 7n and that was 5n. So write an expression that represents the perimeter of the tile. We know that the perimeter is the sum of all the sides, right? So you could just say perimeter equals 7n plus 7n. Since there are 4 sides, we're gonna be adding all the sides. 5n plus 5n. So it looks like 14 plus 10. So our perimeter now gonna be 24 n. Just n, not squared, because it's just the units of the side. So 7n units. We just keep n as n because I didn't give you the value for n. N will be n until the end of the project. We're gonna be ending with n all the time because we're doing representation of the perimeter using the expressions. All right. So how about the area? What will it be? So you know that the area is length times width, right? Okay. So we also know that the length will be 7n and the width is 5n. So we could just multiply 7 times 5 is 35. And we know that n times n is n squared. If you still remember our rules in multiplying exponents, right? Just a little recall, 5 times 5 is 5n, right? Just a little review so that you remember why is that like that. So therefore, n times n is n squared. So anything you multiply together, if you remember the rules in expressions you got. So now our answer here is 35 square units. So I could still gonna write that n squared square units because we don't know what the number for n is. Alright, there you go for question number 2. Alright, for this part, if a bathroom floor has an area of 150 square units, how many tiles would you need to cover the entire floor of the bathroom? Alright, so remember what we got in the previous example? We got 35 square, we have 35 n squared, right? Those are the size of the tiles that you have. So if you have 35, how many 35s you get from 150? So let me just show you. All right, so so in this case we've got 150 divided by 35, so you're gonna get 4. So it looks like we're only gonna buy 4 tiles. 4 times and then you're gonna have 4 times 35 gives you 140. And then you're gonna have 10, and then you're gonna have 4 and 10 over 35, and you could also 4 and 10 over 35. We still have that n squared. We did not take that away, so you could answer it this way, or you could also put them in decimal nearest tenths. So I'm gonna go back. 10 divided by 35 in your calculator, you're gonna get 4.3. You could just simplify your answer or round off your answer to nearest tenth, so you could have 4.3 n squared. So what is this question? How many tiles you would need to cover the entire floor? So approximately, you're gonna say 4.3, so you could say 5 n squared. Don't go down, don't round down, because you might need more tiles. All right, so we might need 5 n squared tiles. Okay, got it? So we keep n squared because I didn't give you the value for n. What if the value of n is 1? So we're still gonna have 5. But if the value of n is 4, so you're gonna have more tiles. All right, cool. So that's question number 2. Let's look at question number 3. You could always rewind this to check what you need. Okay, guys? All right, next question. All right, in this case, if each square tile is 425, how much will it cost to cover the entire floor for the bathroom? So we still gonna keep we still have 5 n squared, right? So we'll keep that away, so we're just gonna use 5. So 4.25 times 5. So in that case, magical tool, So you're gonna have 21.25, and we still keep the insquared because we don't know, we still need that for the entire time. So how much will it cost? So far it's $21.25 n squared. So if this is 2, so 2 squared, so 21.25 times 4. Later on, I'm gonna give an extra credit work to evaluate this, but that will be a separate task, will not be included for this project. All right, so simple as that. So 425 times 5 gives you $21.25. We still gonna carry on n squared because we did not simplify that. We did not change the value for it. All right. Okay. For the last part of the project, you have to explain how you find the total amount you use for the floor. I want you to give the details. I want you to use the word because and point out some details based on the work that you have done. All right. And I can't wait to see your awesome tiles, guys. I will really like to see like tiles. I only see few so far, so I'm waiting for all the tiles that you have. With that said, check the rubric, the details of the working Google Classroom for our tile design. I hope you're enjoying creating the tiles, and we're gonna create one more project before the end of the school year, okay? It's gonna be fun. Alright guys, enjoy your day, enjoy working on your project. I'll see you in class, alright? Bye for now. See you. Good luck. And stay safe always. Always. Alright?